Okay, one way to show, to prove things that triangles are congruent is with side, side, side. So that's showing that all sides of a triangle are congruent. So in the example we have here, AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. And so since all the sides are congruent, ABC, triangle ABC is congruent to triangle DEF. Now, in terms of doing a proof, okay, this is a little more difficult than what we've been doing. Okay, so they give us information. So we're given some statements. Excuse me, I'm sorry. We're given that PQ is congruent to ST and QR is congruent to TR, and R is the midpoint of PS. So we write out our givens. Okay, so we're given this picture, and so we write out our givens. So we write out the statements that we were given. Okay, this is called a two-column proof. Okay, that went by and my voice isn't very loud, so I'm going to try that again. This is called a two-column proof. Okay, the reason it's called two columns is we've got a column of statements and a column of reasons. So we put our statements in one column and our reasons in the other. Okay, so we write out the statements we were given, and the reason that we made these statements is we were given them. Now what we have to prove is that triangle PQR is congruent to STR. Now, so what we have right now is that this side is congruent to this side is congruent to this side. So what we need for side, side, side is to show that this and this are congruent. Well, we have R as the midpoint of PS. So what we can say is PR is congruent to SR by the definition of midpoint. The midpoint cuts it in half, and so by the definition of midpoint, this is congruent to this. And so triangle, now by that we have three sides are congruent, and so triangle PQR is congruent to triangle STR by side, side, side. Okay, we have to remember the midpoint definition though in order to get that. Okay, if you don't remember the definition of midpoint, it's not going to work. Okay, let's take a look at our next one. We've got JL is congruent to NM, and K is the midpoint of JN and LM. So JN is K is the midpoint, and LM, K is the midpoint. So we're only given two things. Okay, so we write down our givens. Now, from here, we can use the definition of midpoint again. JK is congruent to NK. So JK is congruent to NK by the definition of midpoint. So this is congruent to this. So now we have two sides. Now we just need to show that LK is congruent to MK. And again, we can do that with the definition of midpoint because they told us that K is the midpoint of LM. And so now we have three sides and so side, side, side. Now, you could have switched the order of these two, and it wouldn't have made a difference. So if you're doing this and you want to do LK, you see LK is congruent to MK before you see JK and NK, that's fine. Okay, the order in this instance doesn't matter. In some cases it will as we do more of these, but in this case it doesn't matter because we still get to the same point. Okay, now again, we're given two statements. AC is congruent to AD, and CB is congruent to DB. Okay, so we write down our two givens. We need a third side. Well, the third side is right here, AB. It's the third side for both pieces. So how do we show that? Well, we have to use an old algebra property. AB is congruent to AB. It's congruent to itself. The property here is the reflexive property. Anything is congruent. Anything is the same as itself. And then, because of that, we're able to say side, side, side. Okay, from here, we move on to side, angle, side. Now, in order to show side, angle, side, we have to show that two sides and the angle in between are congruent. So we have two sides and the angle in between. So AB is congruent to DE, angle B is congruent to angle E, and BC is congruent to EF. So therefore, by side, angle, side, triangle ABC is congruent to DEF. So now if I look at these proofs, same idea. We have to look at our givens and what we're trying to prove. Okay, so we write down our givens. We've got two of them here. We're given that JM is congruent to LN, so this side and this side, and we're given that this angle JMN is congruent to angle LNM. And so what we need now is a side. So if we have this angle and this angle, the side we need is MN. And so if we use the reflexive property, we can say MN is congruent to itself. And then by side, angle, side, the two triangles are congruent. Now, I've already obviously marked up the whole triangle, but excuse me. Now, our givens are this side is congruent to this side, and BD bisects triangle ABC. So we write down our two givens. Well, based on this, we can do the two angles, ABD and CBD, by the definition of bisect. It means it cuts it into two equal parts. And from there, with the reflexive property, we can say BD is congruent to BD. And then we have our side, angle, side. If you wanted to switch lines 3 and 4 around and say the reflexive property and then the definition of bisect, switch the angles on this side, you would still have the same answer. We don't necessarily have to go in that order. But we have side, angle, side for the triangle now. Excuse me. I'm very sorry. Okay. Now we're only given one thing for this next one. One given. And that's V is the midpoint of WZ and XY. So WZ and XY, V is the midpoint. So that's our given. So WV and VZ, by the definition of midpoint, are the same. People are loud in the office. Sorry about that. Then we can say angle WVX is the same as ZVY because they're vertical angles. And then for our other side, we use definition of midpoint again. XV, YV. Because we were told it was a midpoint. Now again, we could have done the angle up here and then our two midpoints, or we could have done the two midpoints and then the angle. That doesn't matter as long as we have all three. But then we have our side, angle, side for our triangles. Now for our last example, we have our two givens. We have that this is congruent, and we have that they are parallel. Well, since these are parallel, then angle GJH, so this angle here is going to be congruent to IHJ because they're alternate interior angles. And then we use the reflexive property to say HJ is congruent to JH. So this is equal to itself. And then side, angle, side, because we have side, angle, side. Side, angle, side. Okay. And so that's it. There are other ways to prove triangles, but those are the two we're going to focus on today. All right. As always, if you have questions, let me know, and I will see you in class.